You can ask me. Tangent, I don't know, I'm just picking 3 pi over 2. I'll say I have no clue. But I know that it's sine over cosine. Negative 1 over 0, it does not exist. You can say find cosine pi. Cosine sine, negative 1. Anything you want, but you have to remember 1, 0, 0, 1, negative 1, 0, 0, negative 1. And you will always know sine, cosine, tangent, you can calculate, cotangent, you can calculate. So now here, if you say, okay, what about cotangent? 3 pi over 2. It's the reverse. So it's 0 over negative 1. Well, this one exists. It's 0. That's all you need to do. Can you use a calculator on this? Yes, you can. Why? These are just, everyone knows this. Before we got to trig, we needed to know how to read points from the coordinate system. That's all you need to remember. Okay, so let's see. Let's see on the handout, just 1 second to see, and we'll choose the examples in a minute. Yeah, so let's go to the book, because I don't have any examples here. I don't see anything from 5.3. So let's go to the book, and 5.3 is page, what page is it? Page 433. And then we'll choose from there. 433. 433. Okay. Okay. A point on the terminal side of an angle theta in standard position. So I'll explain again standard position. So let's talk about standard position one more time. Standard position for an angle means, this is not a unit circle at all. Sorry about that. So standard position means that the initial side is on the positive side of the x-axis, and the terminal side anywhere. Here, 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 anywhere. So this is the initial side, this is the terminal side, and this is angle alpha. And this is the standard position. So back to the book. So a point on the terminal side of an angle theta in standard position is given. So they give us those points. We are going to choose, you choose, I choose. Find the exact value of each of the 6 trigonometric functions of theta. So let's use a point. Anyone would like to choose a point? If not, I will. Okay, I'm going to choose 13. Is anybody with me?
Yes.
Thank you. So the point is 2 comma negative 3. Okay. So 2 for x, negative 3 for y. Here's the point. Sorry. So 2 for x, negative 3 for y, this is the point. Okay. I'm going to connect the origin to the point. The angle is in the standard position, which means it starts here and it ends here. So this is the angle. Now, they didn't tell us whether it's a positive or a negative angle. A point on the terminal side of an angle in standard position is given. Find the exact value, so it's clear. Okay. Of each of the 6 trigonometric functions of theta. Okay, fine. So this is our angle theta. I have to determine, and we already have, the height, which is this. The height, remember, is the opposite. So because it's the opposite, This will have to be connected to sine in a moment. I shouldn't write sine theta, because I can't write sine theta because I have to write negative, right? So this piece, as in length, let me just identify it differently, because we have to talk about the sign, SIGN of these. Okay, so this is 3 units, and this is 2 units. I have to determine the hypotenuse. Well, a leg squared plus a leg squared equals the hypotenuse squared. So 4 plus 3 squared, which is 9, equals 13. I have to take the square root, so this piece, just this piece, the hypotenuse, is the square root of 13. They're asking us to determine 6 trig functions. Okay. Now, what I would like you to say is that's not possible. Please say it's not possible. How can you determine trig functions for an angle that doesn't fit in a right triangle? What are you talking about? I want you to say that to yourselves. What is she talking about? This is an angle that is so big, it's bigger than 270 degrees. How can this angle fit in a right triangle? Why is she talking about 6 trig functions for such an angle? Well, it turns out that the trig functions are periodic functions. They do exist. The main definition for sine, that's what it is. So for sine of this angle is the opposite over the hypotenuse. But what about these kind of angles? Well, because the trig functions are all periodic functions, they repeat and repeat indefinitely in chunks. Sine, cosine, secant, cosecant have a chunk of 2 pi. But tangent and cotangent, they repeat in chunks of pi. I will get to this. I don't want to overburden you right now with this. But just remember, there is no contradiction. Indeed, this does not fit in a right triangle. But we can still find its sine, cosine, tangent, cotangent, secant, cosecant, because these functions are periodic functions. We're going to talk about this in a minute, about the period for all of them, but not now. So there is no contradiction there. Okay, then I have to remember that sine is measured on the y-axis. So sine is a positive number in the first and the second, but it's a negative number in the third and the fourth. Because the terminal side is in the fourth quadrant, sine has to be a negative number. Okay, so sine theta is opposite over the hypotenuse. 3 divided by 13, but it has to be negative. Negative 3 divided by 13. And we have to rationalize. So sine theta equals negative 3, the square root of 13 over 13. Let me say this one more time. Sine is measured on the y-axis. So those top quadrants, if the terminal side is in this quadrant, in these two, sine will always be a positive number. It turns out that this angle has the terminal side in the fourth quadrant. In other words, it ends below the x-axis. Well, therefore, sine is a negative number. Cosine is measured on the x-axis. This side, I'm going to use a different color for cosine. So these are the signs for cosine. I'm going to circle them for the cosine. So these are for cosine. So it's measured on the x-axis. This piece plus plus, this piece minus minus. If the terminal side ends in the second or the third, the cosine will have a negative value. But in this case, cosine will have a positive value because the terminal side is in the fourth quadrant, adjacent over the hypotenuse. So cosine theta is adjacent, which is 2 over the square root of 13, and that will be positive. 2 over the square root of 13 because the terminal side is in the fourth quadrant. 2 the square root of 13 over 13. Now I would like you to say something else. I would like you to say, hey, you're talking about this angle, but you measured everything based on this angle. The 3 over the square root of 13 and the 2 over the square root of 13. What are you doing? Okay, that is a very important angle. It's called the reference angle. Because this angle cannot fit in a right triangle, I have to base everything on this. And what is this? How do I determine it? It's the acute angle. So it has to be smaller than 90 degrees. Acute angle formed by or between the terminal side and the x-axis. That's the reason why I based everything on this. Not on this, because this is not acute. Acute means smaller than 90. This is obtuse. You can say, why don't you use this one? First of all, it's obtuse. Okay? Now, let's look at all possibilities. And there are only 4, because there are 4 quadrants. If the terminal side is in the first quadrant, the angle is also the reference angle. If the terminal side is in the second quadrant, I determine the sine, cosine, tan, for this using this reference angle. The acute angle formed between the terminal side and the x-axis. Okay, if I have, of course, this is the initial side. If I have an angle in the third quadrant, this is the acute angle that is the reference angle. This angle will give us the sine, cosine, tangent, for this big angle. And finally, the example we just had with a terminal side in the fourth quadrant. This is the angle, and we are going to base everything on the reference angle. Reference angle, reference angle, reference angle, reference angle. Always the acute angle formed between the terminal side and the x-axis. So then, now it makes sense. This gives us, this piece, this angle here, gives us the sine, cosine for this angle. And this one fits in a right triangle. Now, we're asked to find 6. We found sine and cosine. Do I need this again? Of course not. I have sine and cosine. That's all I need. So what was it? Sine theta equals -3 the square root of 13 over 13. Also, I'll put it in parentheses because I may need this for simplicity. And cosine theta is 2 over the square root of 13, the same thing with 2 over the square root of 13 over 13. Do I need this? Oh, absolutely not. I'm done with it. Why? Because I'm asked to determine the other 4. I'm not going to look at that. I don't care. I know the tangent theta is this over this, so it's negative 3/2. I know that cotangent theta is 1 over this, negative 2/3. I know that secant theta is 1 over this, negative the square root of 13. Oh, it's 1 over this, sorry. Oh, it's 1 over cosine.
Wait, Professor, when you're saying
Yes.
whatever is equal to 1 over something, you're saying like we're dividing 1 by whatever
Of
fraction?
course. Sine over cosine is tangent. When I divide this by this and I flip, I get negative 3/2. When I flip this, I get negative 2/3. Absolutely. Is that okay? These are the definitions we discussed. Please let me know if this is okay.
It's okay.
Now secant is 1 over cosine. So I have the square root of 13 over 2. And finally, because I have that in the middle, so cosecant theta is 1 over this, negative the square root of 13 over 3. I don't need to look anywhere because I know the formulas. Sine over cosine, this over this is negative 3/2, because when you flip, you will simplify the square root of 13, and you get negative 3/2. Cotangent is 1 over this. Secant is 1 over this. And cosecant is 1 over this. Now, see what happens with the signs. So let's talk about that for a moment. So back, I would just want to create a new. So I have sine in red. Positive, positive, negative, negative. I have cosine in black. Positive, positive, negative, negative. I have tangent, and I think that's enough. I have tangent and cotangent, both of them together. Of course, plus and minus, plus and plus, minus and minus. How come? Both positive, tangent and cotangent are positive. Both negative, tangent and cotangent are positive. One positive, one negative, tangent, cotangent, negative. One positive, one negative, tangent, cotangent, negative. What about cosine? Cosine has the same sign with secant. How come? Because secant only has cosine in it. So if cosine is positive, secant will be positive. If cosine is positive, secant will be positive. If cosine is negative, secant will be negative. If cosine is negative, secant will be negative. Same thing with sine and cosecant. If sine is positive, cosecant is positive. If sine is positive, cosecant is positive. If sine is negative, cosecant is negative. If sine is negative, cosecant is negative. So these go together, these go together, these go together. What do you have to remember? The only thing is positive for cosine, positive for sine, and the rest will follow. Positive for cosine, negative for cosine. Positive for sine, negative for sine. Okay, let's choose other problems. You choose. Let's see how I am with time. Okay, let me, 1 second, don't say anything. I just